Hi, today we're talking about the Unit 7 molar mass worksheet. Yesterday you had numbers 1 through 5 due, and today we are working on numbers 6 through 10. So the purpose of this video is to help those who are struggling. There's a good portion of people who did everything just fine, and then there is another segment of the class who is struggling, and whether that is, I don't know, it's different factors. So I'm going to go through a couple of these in numbers 1 through 5, and not all of them. But I just want to make sure that we have a good understanding before you get into today's assignment so we can fix problems now instead of later. In order to do this assignment, you're going to need three things. One, a periodic table. Two, you're going to need a calculator. And number three, a pencil. For now, what you need to do is the table method. And so I'll go through and I'll show you the table method, and then I'll show you the faster method. The table is not the fastest, but the table helps us with some later ideas in this unit. And so that's why we want to make sure that we understand the table method. So the number one, we're looking at Na2S, sodium sulfide. And so I'm just going to make my table right here. So in this first column, I put my elements that are involved. In the second column, it's the molar mass. So this is where I go to my periodic table. For sodium, the molar mass, according to the periodic table that I gave you for your binder, 22.989770. And it's going to be just fine if you round these to three significant figures, and it comes out to 23.0. Let me real quick show you how I think maybe some of us are experiencing rounding issues. So three significant figures, and I have to remember that the biggest number is the first significant figure. So here's the first one, here's the second one, here's the third one. Bigger number means more important. It should have a greater significance. So this tells me that I want to round it off here. But it's not 22.9. It's 22.989770. And so, if you just remember your basic math rounding rules, the number after tells us if it rounds up or rounds down. And an 8 tells me it's going to round up. And so that's why it's 23.0. Sulfur, same idea, 32.066. We want three significant figures, so 1, 2, 3, and we need to round it off here. And we have to look at this next digit, this 6, to tell us round up or down. 6, of course, rounding rules says round up, and so 32.1. And these have units. That's grams per mole. That's grams per mole. It doesn't really have to be in the table. You just want to make sure that at the end we include the units. Then quantity, that's the number from the chemical formula. For sodium, it's 2. For sulfur, it is just 1. And here's what we're doing. We are multiplying on each line. So basically 23 times 2 equals 32.1 times 1 equals, And so 46.0, 32.1, and this column's label is total. And at this point, what I'm going to do is just add everything in this column. 0.1, 8, 7, that's 78.1, and the units are grams per mole. And this is the answer that I should arrive at. This is 3 significant figures. Now, we use Prism. It doesn't grade significant figures very well, which means that I have to set the error limits really tight in order for it to catch this. So if you put this exactly 78.1, it'll give you the complete points. I have a few people who are putting in 78.0. That's improper rounding somewhere. And so you just need to be careful how you round it. You won't get full credit if you're rounding incorrectly. And if the significant figures are off, Prism might catch it, and you'll also get 50% off. So I want to keep this video short. We'll just do one more, and it'll be N2O5, dinitrogen pentoxide. So let's go ahead and start our table. Nitrogen and oxygen are the elements involved. Molar masses. So from the periodic table, nitrogen 14.00674. And to 3 significant figures, it's 14.0. Oxygen is 15.9994. We want 3 significant figures. Tells us we're going to round it off here. But it's not 15.9, it's 15.99. This 9 says we're going to round it up, and we end up with, it's going to be 16.0. When we round this 9 up, it makes a 10. That makes the 5 to a 6. Quantity comes from the chemical formula: 2 nitrogens, 5 oxygens, and then the totals. So 14 times 2, let's write that in. The multiplication sign and the equal sign are not necessary here. I just want you to see it. 28.0 and 16 times 5 is 80. 80.0. And so when we add these together, 0.0, there's 8, there's 10. And so according to our basic addition rules for significant figures, this 0 matters. But the way this is going to work is we're going to use 3 significant figures, and so we're just going to make it 108 grams per mole. If you have questions, send me an email. We can set up a time to meet on Google Meets, and we can figure this out. Have a good day.